Okay, I'm going to try to work through the practice quiz a little bit here. And let me show you what this first question is saying. So we have code at the beginning, just like last week. And question one says, consider the C++ program given above. The program will output an infinite sequence of numbers. What are the first 5 numbers in the sequence? So we basically just want to look at this code and kind of parse it in our brains and figure out what the output is going to be. Okay. So you can see that the code is going to declare an integer an integer a and its initial value is 1, and an integer b and its initial value is 0. Maybe over here I'll just kind of keep track of what the values of a and b are. So here's a and here's b. Please don't help me. And okay, so initially the value of a is going to be 1 and the value of b is going to be 0. So we can kind of think of this as, step 0 or something. Okay. And alright, so we also have this temporary variable, and I'm just not going to worry about that for a second. So maybe I should keep track of what the output of the function is. So here I'm going to list the output. Alright. So you can see that the first thing the program is going to output is just 1. Okay, so that's the first number in the sequence. And now we're going to go into this while loop. And it's an infinite loop. Generally, you don't want an infinite loop in your program. Sometimes you do, like your operating system works on the basis of an infinite loop, but usually you want your program to eventually come to a stop, and so you want to put some condition here that will eventually be false, but this program is just going to output an infinite sequence of numbers, so the while loop goes on forever. Okay, so this first line inside the while loop tells you what the second thing the program outputs is going to be. It's going to be a plus b. You can see here that it's just going to be 1 plus 0, right, is 1. Okay, so we only have to say what the first 5 things are, so we're 2/5 of the way done. Now we store the value of a in temp, so maybe I should put temp here, so let's keep track of temp a little bit. Temp. Okay, looks like somebody scrawled that on the wall with blood in a horror movie, but it says temp. And in temp I'm going to put the value 1, okay? And now a is going to be set to b plus a. So that's 0 plus 1 is going to be 1, right? Alright, and now b gets the value of, you can see here in this last line, b gets the value of temp, which is 1. Okay. Alright, so this is kind of like, step 1, step the first. Okay, now we hit here and we go back to the beginning of the while loop. Okay, and it says cout a plus b. Alright, so what is a plus b? It's going to be 1 plus 1. So that's 2. Right? And so, okay, now temp gets set to a, which is 1. Okay. And now a gets set to b plus a, so now b plus a is actually 2. So it's 2. Alright, and now b gets set to temp, which is 1. Okay, so this is like step 3. Alright, doing pretty well so far. And, alright, so I believe that I'm looping back here now, right? So we cout a plus b, which is 3. Alright, getting pretty close to being done. And now temp is set to a, which is 2. So now this is 2. Okay, and b gets set to temp. And wait, sorry. It's kind of hard to keep track of the counter here in my head. So this is the line that we're on. A is getting set to b plus a, which is 3. Okay, and now b is getting set to temp, which is 2. Alright, so now we reached the end of the program. Maybe I should erase this little dash here. Okay, and we're going to go back to, I just ruined my brush, now we're fine. So I go back here to the beginning of the while loop, and it says cout a plus b. Okay, so that's 3 plus 2. This is actually the end of the program. I mean the end of the program as far as we're concerned, because this says the program will output an infinite sequence of numbers. What are the first 5 numbers? And we did it. No problem, no problemo, right? It's just those. And if you experiment a little more, you'll see that this program is outputting something called the Fibonacci sequence, and each subsequent number is just the sum of the previous 2. So that's what the program is doing. So the next one will be 8, and the next one will be 13, and so on. Okay, all right. So now we have problem 2 is a question on logs. Okay, so let's just remember, what is the definition of a log? I hope you can read this. This says log base A of B is equal to C if A to the C equals B. So it's just finding the secret number C such that A raised to C is equal to B. Okay, so with that in mind, let's look at the first question here. So we want to find, we have 10 to the blank is equal to, what number is this? This is 1,000,000. Okay, so 1,000,000, there's a couple ways you could go here. You could just know that 1,000,000 is 10 to the 6th power. Okay, and that means that you can read right off the bat that C is 6, right? Another thing you can do is count the zeros. So maybe those kind of amount to the same thing. So when you have 1 followed by a bunch of zeros, that's just the same thing as 10 raised to n, where n is the number of zeros. That's how scientific notation works, right? So when you have these nice powers of n, log is pretty easy. So this first question, the answer is just 6. Okay. All right, the second question is a little harder. Now we want 8 to the blank is equal to 2. Okay. All right, so I'm picking these numbers so that nice things happen. And what's the relationship between 2 and 8? I know that 2 cubed is equal to 8. So we want to relate 2 and 8 with exponents. That equation comes to mind. So this is just a reminder of how fractional exponents work. What is, if 2 cubed is 8, then 8 to the 1/3 is 2. Okay, and that's because by definition, when you have a fractional exponent like this, what this means is the cube root of 8, and what that means is exactly the number which when cubed is equal to 8. And so what we want here, we're trying to solve this, right? We're trying to find this special C that makes 8 to the C equal to 2, and the answer is going to be 1/3. So the answer for number 2 here is 1/3. Okay. And this one is similar. Number 3 is similar. Okay, so we want 9 to the C is equal to 1/3. And we want to find what C is. All right. So it's kind of funny that one thing you could do is use log to solve this equation for C. But let's try to do it just by thinking. Okay, so just by kind of puzzling things out, there's going to be, since I made up this problem to be nice, there's going to be some relationship between 9 and this number, right? And you can see that the square root of 9, oh, it's helping me again. The square root of 9 is 3, right? Okay, so the square root of 9 is 3. And what's the relationship between 3 and 1/3? Well, 1/3 is the reciprocal of 3. And the way you say that in exponents is that 3 to the -1 is 1/3. Just by definition, when you have -1 as an exponent, what it means is take the reciprocal. So in this stage, I can transform this into this kind of thing if I raise both sides of this equal sign to the -1 power. So that gives me 9 to the -1/2 is equal to 1/3. Okay, because over here what I did was raise both sides to the -1, right? So 3 to the -1 is 1/3, and 9 to the 1/2 to the negative 1, though negative 1 multiplies n and becomes minus 1/2. And that's, maybe we should just say here, okay, so we were trying to solve for this c, right? So the answer is minus 1/2. So minus 1/2. And that's it. So I'm just going to stop this thing recording if I can.